Okay, so last time I guess we went over the first half of module one. So let's try to recap the last portion of that discussion. I guess we ended up near after definition four, which is about subspaces. So recall that the subspace is a non-empty subset of a vector space that is on its own right another vector space. So if you get the vector space V, you collect some elements of it into a set W, and if that set W proves to be a subspace on its own with respect to the restriction of the addition and multiplication in the parent vector space, then we say that that is a subspace of V, right? Now, I guess went over some examples of subspaces for some known vector spaces. And then I guess the highlight of this discussion, aside from the examples, would be Theorem 3, which sometimes is called the compact criterion for checking for being a subspace. Right, so this gives us a shortcut in proving that a set is, or a non-empty subset of your vector space is a subspace, right? So we said there are how many? There are 6 or 7 properties that we need to check so that we can conclude that a set is a vector space. But in order to prove being a subspace, we only need to check 2 things. Is that subset closed under vector addition and scalar multiplication? So you only need to check 2 things. And I guess we devoted a good portion of our discussion last time thinking about Theorem 3 because I did not include the proof here, but we said that by inheritance, all the properties of the operations are satisfied on the subset, right? And then the vector additive identity and the scalar multiplicative identity will also be necessarily be in the subspace if it would be closed under vector addition and scalar multiplication. So from now on, if I ask you to prove that a set is a subspace of another set, then all you need to do is to check, are the sum of 2 vectors in that subset also in the subset? And is the scalar multiple of any vector on that subset is also in the subset? And if those 2 conditions are met, then we can say that the non-empty subset is indeed a subspace, all right? And then here are some, I think we stop here at proposition 4. Proposition 4 gives us, oh yes, Ms. Mamao, you have a question?
Sir, may I ask, when you're asked to prove to be it for a vector to be a proper subspace of a vector space, when you say proper, do we need this showing that the set is a proper subset would suffice to become a proper subspace?
Yeah, that's correct. Because I guess we defined what a proper subspace is somewhere here on top. Let me just recall. Kasi when you're talking about math, dapat medyo may pagka-lawyery ka eh. So you need to go by the letter of the statement. So let's see. Because it depends on how we define it. But I guess you're right. But let me just be sure about it. So here.
Kasi sir, we have a homework that you wanted us to prove it's a proper subspace. So I wanted to know what else do we need to.
Yeah, good catch. Because I think there are a couple of submissions already to that problem, and they forgot to prove that it is a proper subspace. So let's see. So we say that the set containing the vector additive identity is called the trivial subset, the trivial subspace, while the set itself, of course, it is a subset of itself, and it is also a space. So technically, it is also a subspace of itself, and we call it an improper subspace of itself. Now, all other spaces are called non-trivial. Oh, yeah, probably that's a lapse on my part here. I should have written here are called. Yeah, I thought I put somewhere what a proper subspace is.
Exactly, sir. Kasi meron lang po non-trivial subspace.
I thought what I wrote here is a proper subspace, not a non-trivial subspace. Yeah, maybe let's change this. And then I need to go back to those which I graded already. So these are called proper subspaces. Yeah. So please correct your copies of the module. On page 36, instead of non-trivial subspaces, let's call them proper subspaces. So all other subspaces of a vector space, other than the trivial and the improper subspace, would be called proper subspaces. So if you want to show that a certain subspace is proper, then all you need to show that it is not trivial and it is not improper. So papakita nyo na it contains something more than the vector identity, and but it doesn't include all elements of the original vector space. So it must be larger than the set containing the additive identity, but smaller than the actual vector space itself. So that's what we call a proper subspace. Oh, thank you for pointing that out. Yeah.
Thank you, sir.
Yeah, sorry about that. That's an oversight on my part. Yes, Miss I, you have a question?
Sir, yes, sir. To point out, sir, that subspace is not a trivial subspace, but a proper subspace. Is it enough to show that there's at least one more element aside from that's in the
Yeah, that's
subspace?
correct. Because we know that the additive identity in the parent vector space is an element of all other subspaces. So that means nandun na siya palagi. So if you will be able to find one more element aside from the identity, then it will qualify to be a non-trivial subspace. And then just to prove that it is proper, then pakita nyo lang na it has at least two elements, but not the entire parent vector space. Right? Okay. So yeah, let's go here. Okay. Now I think we stop at proposition 4. Here we say that we give another example of a subspace of a vector space. So for now, we know two subsets of V to be subspaces for sure, the trivial subspace and the improper subspace. So may at least dalawa na tayong alam na subspace for any vector space. Now proposition 4 gives us another way of getting another subspace. So if you will get a collection of subspaces and put that into a set. So if you will collect any number, any finite number of subspaces, and then you get the intersection of those subspaces, then that intersection will also be a subspace of the parent set V. All right. So meron ka nang alam na tatlong subspaces, you just get their intersection, and what you will get again is another subspace of the parent space. Of course, it doesn't make sense to just work with the improper and the trivial subspace, because their intersection will give you the trivial subspace. But if you have two or more proper subspaces, you take their intersection, you will get another interesting subspace. And that's what this proposition is claiming. I don't know if we will be using this a lot, proposition 4, but it is a good proving exercise, an example of how to use theorem 3 in order to prove that a non-empty subset is a subspace of a vector space, right? So that's why I included it here. Oh, by the way, have you guys wondered why sometimes I call a result a theorem, sometimes I call it a proposition, sometimes it's just a remark, sometimes it's a lemma, a corollary? I don't know if you guys have seen this in your math classes, or do you still remember what are the differences between these mathematical results or assertions? Baka lang nag-wonder kayo, bakit minsan proposition yung tawag ko, minsan theorem, minsan lemma, minsan remark. Any idea? Just mga side notes lang, no? But I hope this will help you when you're teaching math courses later on. Yes, somebody's trying to answer.
A theorem, sir, is a proposition that has been proven.
Well, that's true, but what about this proposition? I have a proof for this proposition.
Yeah. True.
Okay.
I'm not
nice
sure, sir, but then one of the books that I've read before, sir, is that I'm on a definition. A proposition is just a statement that you need to prove. So it has not been proven before, so you need to prove that one. Then, of course, a theorem is a proposition that has been proven. And then a lemma and a corollary are theorems that are supporting theorems to an already established theorem.
Uh-huh.
That's how it was defined in the book that I've read.
Yeah. So sometimes it varies from author to author actually, but I guess for lemma and for corollary, medyo universal yan. So we are often, I guess we are used to having theorems in classes, right? So theorems is our assertions of facts that are proven to be true. So perhaps let me write that down probably. Yeah. So dun tayo familiar, yung mga theorems, these are statements that we try to prove, right? Meron pa nga dapat before the theorems, you have your definitions of terms or definition. Of course, this is self-explanatory definitions. These are we attach meaning to some objects in our universe or in our universe of discourse. But definition, a nice definition or a good definition has two parts. It should have a genus and a differentia. Genus is one thing or one characteristic of the term to be defined that puts it that shows its relation with other objects in your discourse or in your universe. So ano yung relation niya dun sa mga existing terms dun sa ating mathematical discourse. Meanwhile, differentia is what sets the term to be defined apart from all existing terms in our vocabulary. So genus, how it is related to other words in our vocabulary, differentia, how it differs from all other words, and what sets it apart from all those other objects, right? And then after you define any mathematical discourse should work with axioms or assumptions. These are things that are assumed to be true for the sake of what is to follow. Because you cannot start a mathematical discourse without having some assumptions, some tacit assumptions, things that need not be proved. So sometimes axioms are also called postulates. These are statements that are assumed to be true, no need for a proof, right? But for axioms and postulates, we have some criteria. What makes a set of axioms mathematically desirable? So nandiyan dapat yung consistency, meaning the axioms will not contradict each other. Then it should be complete, meaning you should be able to get all of the possible theorems or results based on this limited number of axioms and so on. I guess there are 3 or 4 properties of a desirable set of axioms. I just forgot the other 2 right now, but I hope you will.
Consistency and independence, sir.
Oh yeah, that's right. Thank you. Independence meaning none of the axioms can be proven from the other axioms. So yeah, dapat mag-start ka with a set of assumptions. So, but I think one of the groundbreaking results in modern mathematics is the incompleteness theorem by Girdle. So that means in any mathematical discourse, if you have a set of axioms that is independent, consistent, and what's the other one? I forgot the other one. Then it cannot be complete. Meaning, even if you have those 3 nice characteristics of your axiomatic systems, there are still some problems that you cannot solve inside your mathematics or inside your mathematical or logical discourse. So laging may mga problems na walang solutions in any mathematical system. And that's groundbreaking because people are trying to solve everything. But Girdle said, no, that can't happen. There are really some problems. Even how well you define your mathematical system, there are still some problems that cannot be solved. There are theorems that cannot be proven. That's why minsan nagdududa na yung mga tao. Maybe some of the Millennium Prize problems are not solvable within the existing mathematics or within the framework of our existing mathematics. So yeah. So going back to theorems, so I know you're familiar with theorems. These are statements or mathematical assertions of facts that are proven. Now, propositions, on the other hand, some texts doesn't do not differentiate between theorems and propositions. So sa kanila parehas lang yung theorems and propositions. For one, I think Golan calls all of his results propositions. But for me, I would like to call propositions as minor theorems. So ito yung mga statements that the only point of me including them in the modules or in the discussions would be to illustrate how to use the theorems. So the beauty of or the utility of propositions would be on the proof. It would be a practice of using the theorems and the definitions in order to prove them. So these are minor theorems. So siguro just to guide you also in reading the module. So if you see something is a proposition, maybe it will not be too useful. The utility of that statement is just to illustrate how the theorems work or how they are used in certain contexts. So that's my criteria when I call a certain statement a proposition. Now, before a theorem, you will encounter some lemmas. So lemmas are also theorems on their own, pero the value of a lemma is for the theorems that they will produce. So yung lemma, siya yung ginagamit na statement para ma-prove yung isang theorem. So it is a theorem that is used to prove a more major theorem. So parang siya yung stepping stone in order to prove a certain theorem. It's just that the result of the lemma or the consequence of the lemma as a more far-reaching implication or consequence. That's why the theorem, that result is called the theorem, and the preceding result, which is a theorem on itself, is just called the lemma. So kung magbabasa kayo ng lemma, usually lemmas or the use of lemmas, the value of lemmas do not go beyond the theorem that they prove, or the theorem in whose proof they are used. So yung value ng lemma ay para lamang dun sa, or most likely ay para lamang dun sa proof ng theorem. So if you have a long book that you are trying to review, if you have a lemma, then do not bother too much about the lemma, because the value of the lemma is for the proof of the succeeding theorem. On the other hand, another type of a theorem is a corollary. Okay, the corollary is a theorem on itself, but it is a direct consequence of the preceding theorem. So parang ano lang siya, parang anak lang siya ng theorem. So you can think of lemma to be the father or the mother of a theorem, but the theorem is the major one, and then the corollary is just an offspring of the theorem. So para lang medyo mag-guide kayo on how to read the modules or how to read any mathematical text. All right. So having said that, going back to the module, so we go to proposition 3, and I say here it's a proposition, so it's not that major, but the value of this proposition is to help us understand how to use the preceding theorem, theorem 3 or the compact criterion, into proving statements like proposition 4. So proposition 4 is claiming that the intersection, I call it curly W, of some collection of subspaces is also a subspace of the vector space V. Again, we want to show that curly W, being the intersection of a collection of subspaces, is another subspace. And you should be able to recall, oh, from now on, I won't use the definition to prove being a subspace anymore. I'll go to theorem 3, the compact criterion. And what the compact criterion says is that I only need to get 2 arbitrary elements of the vector of the subset and show that their sum is also in curly W. And then I'll take an arbitrary scalar, multiply it by an arbitrary vector, and the product, the scalar product, must also belong to curly W. And if that will happen, theorem 3 will automatically kick in, allowing us to conclude that indeed curly W is a subspace of V. All right, and let's read the proof. So that's why here I took 2 elements, arbitrary elements of V and W, no restrictions on them. So these are generic elements of curly W. And what is curly W again? Curly W is the intersection of the collection of subspaces. So ano yung consequence pag sinabi ko na si V and W ay elements nung subspace, ay element nung intersection W? What is its direct consequence? But I hope the starting point is clear, guys. I want to use the compact criterion. That's why I took two generic elements of curly W. And my goal is to show that V plus W is also in curly W. So I'll start with that. What would be my first argument? Probably I'll make use of the definition of W. So ang alam ko pa lang so far, si V and W were chosen randomly or chosen arbitrarily from the set curly W. So what does that mean? Assuming din nyo pa nakikita yung rest of the proof. Anybody? What does that mean? For V, what is the direct implication of V and W being in curly W? Or nawala na naman ba ako sa call? Hopefully I'm still here. Okay, Mike, go.
That V and W are in all the curly W sub i's.
Exactly. So, yes. Yeah, that's right. Si V and W ay nasa curly W. But curly W is the intersection of curly W sub i's. So for an element to be in the intersection of some sets, it must belong to all of those sets, right? So that's why I said here, then V and W will be on all of the curly W sub i's. Kasi nasa intersection siya ng lahat ng mga W sub i's. So ibig sabihin, dapat nandun siya sa bawat isang W sub I. Alright? But what do we know? Each Wi is a subspace of V. So ibig sabihin, by Theorem 3, remember, Theorem 3 is an if and only if statement. It goes either way. So that means if V is a subspace, then W is closed under vector addition and scalar multiplication. And since it is if and only if, the converse is also true. That means if W is closed under vector addition and scalar multiplication, then automatically it will also be a subspace. So I use the forward implication here. Dahil subspace yung mga W sub i's, so ibig sabihin yung V plus W ay nasa mga W sub i's din. Kasi yung V at W ay nasa bawat isang W sub I, bawat isang W sub I naman ay isang subspace. So ibig sabihin, by Theorem 3, or by closure under vector addition, the V plus W, or the sum of V and W, must also belong to each of the W sub i's. At dahil yung V plus W nasa bawat isang W sub I, their sum must also be in the intersection of the curly W sub i's, and hence proving this result. So closure under vector addition is done. Is that clear? Yeah, give me guys a thumbs up if that is clear, or if you have questions, raise your hand.
It's okay, sir.
Okay, good. And then a similar argument will hold for scalar multiplication, right? So again, take a scalar alpha in your field F, and then by being subspaces, then by closure of multiplication on each of the subspaces, then alpha V will also be in each of the subspaces. So it is in every subspace, then that means it would be in the intersection. And hence by proposition 3, then it should be fine. All right? And that ends the proof. Okay. So again, nothing spectacular about proposition 4, but the value of proposition 4 is it will just help us to get used to using Theorem 3 in proving being a subspace. All right. Now let's see what I wrote next. Okay, here we define a linear combination. This is a generalization of the concept of linear combinations that you might have seen before. So we say that the vector V is a linear combination of vectors in a non-empty subset of a vector space V, if and only if that vector V can be written as some sum of scalar multiples of some vectors in capital X. So kung masusulat mo si V as or in this form, then it is said to be a linear combination of the x sub 1, x sub 2 until xn. So it's a linear combination of the x sub i's. Right. Just be clear here, when you say a linear combination, it doesn't matter how many elements of the non-empty set X you gather in order to express set V in this form, as long as the number of addends is finite. So that means it doesn't matter what n is, as long as it is finite. So there are some vectors that can be written as only using one element of X, using two elements of X, and so on. N is not fixed, all right? Now, Ma'am Au, you have a clarification on that?
Sir, does that mean that any vector in the vector space can be written that way?
Well, yeah, you need to be careful about that. In defining linear combinations, we are not just talking about the field F and the parent vector space, but also on the non-empty subset X. So if you are talking about any vector can be written as a linear combination of the elements of the big vector space, then that's true. Pero depende yon sa set X. Kung ang set X ko ay curly V, then yeah, of course, by default, any vector can be written as a linear combination of elements of V. Pero pag maliit masyado yung vector X, then posibleng hindi natin siya magawa. Right. Yes, a follow-up question, Ma'am Au?
Sir, so does that mean, basta sir, so every vector in a vector space, kasi sir, vector space na. So, can be written nga po this way.
Linear combination of what? Linear combination of elements of, what is your set X?
Any other vectors.
Of any, of vectors.
It's possible.
Of any linear combination po of vectors in a set that is a subset of that vector.
Okay. Maybe I can show you a good example of it later. But yeah, if you take X or big X to be the vector space V itself, then this is true. Kasi kung kukuha ka ng isang vector kay V, then that vector can be written as unity times itself. Kasi si little v ay naka-capital V. So ibig sabihin, lahat ng vectors sa vector space is a linear combination consisting of itself. All right? Because I said n is not fixed as long as it is finite. So here, I just used one element of big V in order to write V as to write V as a linear combination. But what if I'll try to another specific example? Probably say, halimbawa ang vector space ko ay R. And then halimbawa ang field ko ay hindi ka pala pwedeng kuning field yung Z, no? Wait. All right. Let's see. Let's call, maybe it's not a good name. Let's call, let's think about it. Script E is the set of all even, let's see. Magiging field ba yan? Hindi, no? Ang set of all even, hindi siya magiging field. Yeah. Let's see. I'm thinking of a good example. Okay. Pwede ko bang vector space bang Z together with usual addition and usual scalar multiplication on the field hindi rin pala field R hindi rin pala pwedeng field R, no? Hi, sir. Hold on. Let me think about a good example here. I was thinking, for instance, kasi for instance, integers. Okay. So kung meron kang integers, yung mga even integers ay linear combination ng mga even integers, right? But yung mga odd integers cannot be written as a linear combination of the even integers, because the sum of two even integers is another even integer. The scalar multiple of any even integer is another even integer. So you cannot generate the odd integers as a linear combination. My only problem with this example is hindi nga pala field ang set of integers. So yeah, but let's see. Maybe this one. Set of all polynomials. I don't know if we have defined this already in our insofar this module is concerned, but let's call P bracket X. This would be the set of all polynomials. So we will prove later, or you can prove that the set of all polynomials of any degree is a vector space over the field R. So ito yung vector space V ko, si F ko ay R. All right. But note that if I take X to be the set of all polynomials of degree 0, P, set of all polynomials P such that the degree of P is equal to 0. So ano lang yung laman ni set X?
Constant function.
Exactly. So these are just the constant polynomials. So, but the set of all constant polynomials will not generate, in terms of linear combinations, the entire set of polynomials. Why? Because if you take a linear combination of polynomials of degree 0 over the field R, then what will you get? Ano lang yung mga posibleng masulat natin as linear combinations of polynomials of degree 0?
So polynomials, 0 polynomials also. Constant.
Yeah, constants pa rin, right? Because when you add constant polynomials, multiples of constant polynomials are also constant polynomials. And when you add constant polynomials, you get constant polynomials back. So the set of all linear combinations with respect to the set X is just the set X itself. So I cannot generate the entire set of polynomials. So kaya hindi necessary na lahat ng vectors, lahat ng element ng vector space can be written as a linear combination of any non-empty subset of V. So nagmamatter ano yung set X. So for instance, sige, wala palang point, natingnan ko lang yung set of all degree 0 polynomial. What if I'll take this one? The constant polynomial 1 and the linear polynomial X. So halimbawa, ito yung set big X ko. So ang laman niya, constant polynomial 1 and the polynomial P of X equals X. So what do you think would be the set of all linear combinations of elements of big X?
So mga linear polynomial.
Yes, they will just be linear polynomials of the form AX plus
AX
B.
plus B.
Yun yung nag-generate niya, but it cannot generate any quadratic polynomial. It cannot generate any cubic polynomial, right? So kaya importante yung non-empty set X. Kasi sa kanya nanggagaling yung ginagamit natin dun sa linear combination. And if your set capital X is not big enough, then you might not be able to generate all elements of the set V.
Okay,
But
sir.
if you indeed want to generate the entire V, then you can make your set X as big as possible. And your main suspect would be the vector space itself, right?
Opo.
So I hope that clears things up. Clear na ba yan?
Yes, sir. Thank you.
Right. So, but anybody else, do you have an idea what would be my big X if I want to generate my curly V? Ano dapat yung ilagay ko dun sa set X para ma-generate ko yung entire vector space of all polynomials? Any idea? Any guess? Try lang. So how can I generate the set of all polynomials? Using linear combinations of what subset? So you can do this by induction, right? So kanina yung mga constant polynomials, pag si set x constant polynomials lang ang laman, constant polynomials lang yung makukuha ko. Ngayon kung si big X ang laman niya ay constant polynomial at saka si x to the 1, nakukuha ko lang ay lahat ng linear polynomials of degree 1. What if I add one more element here? Say I include x squared. So ano yun yung set of all linear combinations of big X? When big X is comprised of 1x and x squared. So ano yung ma-generate ngayon ni big X ko?
AX
Quadratic.
squared. Quadratic, sir.
Yes, lahat ng quadratic of the form ax squared plus bx plus c. Kasi yung a, b, and c, these are the scalars coming from my set, from my field F, right? So na-generate lang ng tatlong element na to ay lahat ng quadratic. So you will see what will happen if you go by the pattern. If I add x cubed into the mix, I'll get all cubic polynomials. If I add x to the fourth, then I will get all quartic polynomials, right? So if I want to generate the set of all polynomials, so one way to generate it without using the entire vector space V itself, then I can let x to be the set containing 1, x, x squared, x cubed, x to the fourth, and so on. In general, x to the n for any natural number n. Tama? So if I will make this to be the set x to the n, where n is any natural number including 0, then do you agree I will be able to generate p bracket x? So kung kolektahin ko lahat ng polynomial ng itsura ay x to the n, where n is a natural number or 0, then I'll be able to generate the set of all polynomials as a linear combination of the big X or the set big X. All right? Okay? Is that okay, guys?
Yes.
All right. Now, since we had been talking about what are all the possible linear combinations of elements of a non-empty subset X of a vector space, then let's give it a name. And for that, we call it curly L of X. So si curly L of X, siya yung set ng lahat ng posibleng linear combinations ng elements ni capital X over the field F. And that's why I mentioned that the set big X is crucial, all right? Because the set curly L of X, or the set of all linear combinations, will depend on how big or what are the elements actually of your big set X or your set X. All right. Then we have here a convention. L of the empty set is the set containing the 0 vector. All right. Because if you go back here, the definition of L bracket X only so far covers non-empty set X, right? But there might be some time when in some of our arguments we might need to have something like what is L of the empty set. Let's define it now as the set containing the 0 vector, right? Then I hope you guys had a chance to look at exercises 7 and 8. These are computational in nature. So maganda siyang exercise. How to show that L bracket X looks like this and how LX prime also looks like this. So the point of exercise 7, oh, by the way, in order to get L bracket X, kunin nyo lang lahat ng possible linear combinations ni X, right? So how will you do that? Well, you can look at it as, okay, alpha 1, 0, 0 plus beta 0, 1, 0, where alpha and beta are any element of the field R, right? Kasi yun yung field F natin. So if you do the addition here, you will have alpha, beta, 0. So that means curly L of X will just be alpha, beta, 0, where alpha, beta are real numbers. And that's how I got that, right? Then it will be a good exercise if you guys can show, if you can compute L of X prime, curly L of X prime, and verify that indeed that should be the same thing as curly L of X. So medyo may babaguhin lang kayo na statements doon. All right? It's just an exercise on logic. And then example 7 is a good illustration that even if you have two different sets, totally different sets, then the set of all linear combinations that they produce might coincide. So X and X prime obviously are not equal, but yet the set of all possible linear combinations from these two sets are the same. So keep this result in mind, right? And then we'll see this later again. Yes, Ma'am Al?
Sir, to do that, to prove that exercise, it's enough that we compute for the coefficients of the linear combination of Lx prime in terms of alpha and beta, in the way you did the example kanina.
Oh, yeah.
Tama
You
po
can
ba?
do that. Sorry. Pwedeng pakita nyo na kasi ang claim dito ay parehas silang equal kay AB0, no?
Yeah.
So equate nyo lang to kay alpha 020 plus
Yes.
beta 330 and show that there exists an alpha and a beta that
In
will
terms of
make
A
this
and B.
equation. Yes, in terms of A and B, exactly. And then you'll be done, right?
Okay, thank
The
you.
point of Okay, thank you. The point of example 7 is just to show dalawang magkaibang sets pero parehas yung kanilang curly L, right? And that would be important for later for later concepts, right? Example 8. This is another nice illustration. It says here that ito yung non-empty set X natin, which is a subset of R3. And then we want to show that the representation for elements of L bracket X is not necessarily unique. That means we can find a vector that is a linear combination of the L bracket of the curly L of X, but the set of scalars used to generate them are different. So kung lagyan mo ito ng alpha 1, alpha 2, alpha 3, alpha 4, and then you take their sum, right? You get a vector V, but you can also generate the vector V as beta 1 plus beta 2 plus beta 3 plus beta 4, where the alphas and the betas are not necessarily equal to each other. So that's what this equation 3 is asking you to do. So in order to solve exercise 8, kailangan nyo lang pumili. Can you give me a vector V that can be written as a linear combination of members of X but with totally different quadruple of coefficients? All right. You can be as creative as possible. Or you can use a solver to do this. But yeah, sa pakita nyo lang na hindi unique yung pagkakasulat sa yung pag-express sa isang element as a linear combination. at least for this kind of bracket X. And usually this is not desirable because sometimes we want the representation to be unique up to the ordering of the terms in your summation. That's why we want to find a unique quadruples. But example 8 shows that we can design a set big X such that the linear combinations of members of those of that set X is expressible in more than one way as a linear combination. So may dalawang magkaibang quadruples of scalars that will generate the same vector space. And that would be a red flag for us for applications to follow. That's why later we'll look at of set X that has some desirable characteristics. Namely, there should be a unique representation for the linear combinations, and that ito yung pinapoint out ni Ma'am Au kanina, that can we find a set X such that all elements of the vector space is nothing more but a linear combination of members of X. And then gusto ko rin na the linear combination must be unique. And then if we will be able to find such a set X, then that would be highly desirable, and we can call that set X by a nice name, as you will see later. All right. But that's for later. Okay. Then you have exercises 9 and 10 here. Okay. Then we have theorem 5. If you have a non-empty set X, then it says here that L of X, or curly L of X, is always a subspace. So this gives us another way of creating subspaces, right? So aside from the two we know, the trivial and the improper subspace, and then we have proposition 4, which tells us that the intersection of any finite number of subspaces is another subspace. Theorem 5 tells us that if you select any non-empty set, all right, any non-empty set X, then you take the linear combination, or you take all the possible linear combinations of members of capital X, then what you'll get is a subspace. And it's not just that. Curly L of X as a subspace has the following interesting properties. Lahat daw ng subspace ni V that contains bracket X should also contain curly L of X. And then curly L of X is the intersection of all subspaces of V containing X. All right. So let's try to see how this were proven. And again, we're reading proofs not because we are doubtful about the theorem, but this might help us practice our proving skills, right? Yes, Jericho, you have a question?
Sure, I don't have a question, but is it possible that you can show us first quite concrete example, because we cannot actually digest starting from the beginning, the exercises on number 7 up to 9. Actually, we cannot see how things will work. Yeah, and from that one, we
Okay. You mean example of concrete examples of curly L of X?
I mean, you mentioned that number 9 will be very important in later discussion, but actually we don't know how will that. No, number 8 pala, number 8. Number 8 will be very important, but we don't know how to start, actually how to begin with solving number 8.
Okay, yeah, sure.
Can you please
yeah. Okay. But I hope you had an idea how to do number 7, all right? And then, so number 8 is claiming that the representation for the elements is not unique, all right? And then we said that you can prove that by showing that you can find discrete quadruples, alpha 1, alpha 2, alpha 3, alpha 4, and beta 1 until beta 4, such that this equation is true. Para mapakita that, or this is one way to show that the representation is not unique, then you construct those representations, all right? So the thing here is, can we find a vector V in R3, right, such that it can be written in two ways like this, right? So maybe let's try to solve that and play with this one. Lipat ko lang siya sa kabilang page. So proof of existence. The claim was that the representation is not unique. Therefore, we should be able to find an element V of R3 such that it has these two different representations. But let's see how these two guys, or how these two spaces are, or how these two sets, or how these two linear combinations are related to each other. Or perhaps let's see how the elements of X relate to each other. So ito yung mga elements natin ni X, ni big X. Okay, can we find a relationship between them? Yeah, because I don't have the solution in mind, because it's crucial. We need to find a V first, and then show that that V can be written as in two different ways. But since I don't have a V in mind, and I'm not sure if any element V can be represented in more than one way, because the theorem says that, the example says that there could be some elements. It doesn't say all elements can be written as a linear combination in two different ways. It's just saying there must be, or there could be, a vector that can be written in two ways. So let's see how these two or these elements of X relate to each other. I mean, let's take a look at the elements of X para makakagawa ako ng isang example. So let's see. Yeah, I'm looking at this 224, 224. Three, 3, 4. Yeah, I'm trying to see which one of these four guys can be written as a linear combination of the other three guys. Ganun ko dinadaya yung problem. So I'm guessing what?
Doc,
let's see.
We're looking for we're looking which of the four elements can be written as
A
the
linear combination of the remaining three.
Of the remaining three.
Yeah. Meron ba? Let's see.
Sure. Di ko lang sure. Ayun, si Ma'am Juana daw po.
Yeah, yes, Ma'am Juana.
I'm not sure, sir, kung 4 or 2.
Yung 4 or yung
Either sa dalawa.
2. 4, you mean this or this? Kasi pag napakita ko na yung isang element ay linear combination ng natitirang tatlo, ibig sabihin hindi ko siya kailangan para ma-generate yung vector V. So I can design my vector V in that way.
So yung 4, feeling ko baka po yung 4, sir. Kasi lahat siya may element. Di ba po magiging ano yun? Alpha 4, 1 plus alpha 4, 2 plus alpha 4, 3. Di pala. Alpha 4 plus...
Yeah.
Is
Ang
1 the
inisip ko
fourth?
rin yung 1, 1, 1. Kaya ko ba siyang isulat as a linear combination nitong tatlong to? Let's see. 0, 0, 4. 2, 2, 0. 2, 0, 0. Kaya ko ba siyang isulat na 1, 1, 1? Tapos magkakaroon ako dito ng scalars sa tapat. Ano dapat yung mga scalars para magawa ko yun?
Sir, R naman po yung scalars po. Ano po?
Right. So posibleng to ay 1/4.
Tapos 1/2. Ay, joke. 1/2.
Panggulo kasi yung
siya.
2
So
dun sa
1/4
gitna.
ulit. Baka 1/4 po ulit. Tapos
So
1/4 ulit sa
second
kabila. Hindi
one.
pala, magiging 1/2 pala po yung gitna.
Yeah. Siguro, kasi kailangan ko itong dalawa, no? 1/4 yon. Gawin kong 1/2 ito. Kaya lang mababago na yung gitna, no? So this would be 1. And then the other one would be... Hindi ko siya pwedeng gawing 1/2. Though mawa 1/2 ko siya, pero magiging ano yung...
2 po yung
Tama.
taas.
2 ba yung taas? Yeah, 2
Kasi po,
magiging 2
magiging
yung
2 yung
taas. 2, 1.
Baka po hindi 1/1/1. Feeling ko po hindi 1/1/1. Pwede pong negative to. Ano po yung i-multiply?
Yep.
Yes,
Scalar,
you can have
pwedeng
actually
negative.
multiple scalars.
Feeling ko po yung 1, yung 4. Kasi magma-minus tong 2. Tapos yung element 2 at saka 3. Element 2 at saka 4. Pwedeng nakamultiply sa 2 yung 4. So cancel siya. Tapos nakamultiply sa 4 yung last. Ay. Sige po, ma'am. Si Ma'am Juana daw po.
Yes, Mama.
Pag sinabi ko pong 004, ang 4 at 2, actually ang iniisip ko po is ang 004 at ang 200, hindi po yung 220 at 111. Oops.
Okay. Yeah, sir, really? May suggestion kayo?
Pero yung kanina, yung equals 111, yung 1/4 yung sa may 004, positive 1/2 yung sa second vector, sir.
Tapos 0 yung last. Kaya lang yung C magiging 0.
0 yung last. Mawawala yung gitna. Hindi, tama.
Tama
Tama
po
pala.
yan. 111 po yan.
So ito yung 111. So ang clue sa akin ay mukhang pwede pa lang yung 111. Yung 111 can be written as a linear combination of the other three. Pero bakit ko nga inisip na gawin to? Why will it help me find a vector V that has multiple representations? Let's see. Alam ko kasi if this, medyo nandadaya ako. Alam ko na kasi yung konsepto ng basis. Nawawala na sa akin yung meta-axiom of ignorance, no? So I know that these three vectors here will give me a unique representation. But if I put one into the mix, that means yun yung nagko-cause ng pagkakaroon ng more than one representation for elements of the vector space. So let's see if I can somehow argue using that. Let's see. So that's 111. Nakalimutan ko kung bakit ko nga ba gustong gawin to. I lost my train of thought. Okay, but let's see. Ano yung set natin? R3, no? And then I have 4 elements. Okay, I'm sure that this will work for any vector V. Okay, so that's 111. I can generate one. Is this the only way I can generate 111? I mean, as a linear combination. So let's see.
Sir, opo. If you just...
Opo, sir.
Yeah.
Sir, yan lang po.
Yung sure na po yung gitna eh.
So
Wala na
ito
po
lang
iba
yung
pwede sa
posible.
gitna.
Alright. So, but
Pero
here,
sir, would it help if you do systems of equation? Kasi you're looking pa for the vector, you don't know how that vector looks like, but it would have the first the vector that you're looking for will have 2 alpha 2, 2 alpha plus 2 alpha 3 plus alpha 4, And then the second row is 2 alpha 2 plus alpha 4 equal to a certain vector. And then yung betas nyo rin po would have that. Tapos makikita mo kung linearly dependent siya
Yeah.
doon sa iba.
But I'm trying to avoid the use of linear dependence kasi
Okay,
nasa
sorry.
next ano pa siya.
Alright.
Kaya medyo
Sige,
dinadaya ko, hindi ko binabanggit yung terms, pero actually yun yung nag-run sa head ko. Paano ko siya ilulusot into an argument like
Yeah,
this?
because you have kasi R3 lang and then you have 4 elements of X.
Right.
So you can express one vector to be in terms of the other three.
Okay. But do you agree this adds up to 2, 2, 2? Dapat, no? Equal siya sa 1, 1, 1.
Yeah.
If I add 1, 1, 1 to it, I get 2, 2, 2. But, okay. But I can also generate 2, 2, 2 this way. I can have 1 half, 0, 0, 4, plus 1, 2, 2, 0, plus 0, 2, 0, 0, and 0, 1, 1, 1. Is this correct?
Opo.
Oh, there you go. That's why I wanted to know which one can be written as a linear combination of the other. So I can cheat a little bit and find two ways
And look
into
for a
writing.
vector
Yes.
that can be expressed. Okay.
Yeah. Though
Pero
it can be
sir,
done in different ways.
yeah.
You can
Sir,
do
can you-
system of equations and so on.
Parang isip ko, sir, ABC. Yung 2, 2, 2, you'll replace it with ABC so you can get generic looking.
Yes, you can also do that. Yeah, that's the habit of mathematicians.
So you have A, B, C, D. So you'll have A, B, C, D, and then D will be in terms of the ABC.
Right.
Parang
Yeah. Though, if you're trying to prove the existence of something, pwedeng magbigay ka lang ng isang specific example.
Okay. So okay na yung ganyan, sir.
Okay na yung isang example.
To
right.
answer 8. Okay po.
Yeah. Let me just try to reread it. What does it say? It said that show that the representation for elements of Lx is not unique. You may choose a vector v and show that there exist quadruples. Yeah. Oh, but the way the question was phrased, maybe Ma'am Ao is correct here. It says here that the representation is not unique.
Yeah.
So that means if I have a vector like this, I can write it as alpha 1, 0, 0, 4, plus alpha 2, 2, 2, 0, plus 0, plus alpha 3,
alpha 3, 2, 0,
0, 0,
and then
plus
alpha 4,
1,
1, 1, 1.
1, 1, 1. All right.
Tapos
Then I can
do this
also
with data.
then you do it
A
with beta.
equals alpha, beta.
So papakita mo na sila.
But at least you saw the concrete example here, 2, 2, 2, the way I cheated a little bit in order to show that I can find two different quadruples whose linear combination or whose resulting linear combination will be 2, 2, 2, right? So that's what is meant by not having a unique representation. So we say that 2, 2, 2 doesn't have a unique representation because we found two different quadruples. The first one is 1/4, 1/2, 0, 1. The other one is 1/2, 1, 0, 0, which gave us the same vector 2, 2, 2. But yeah, Mamao is right in pointing out that the question is quite generic. It's asking us to show that elements or representation of all elements is not generic, right? So, but the problem here is that if I'll try to do it as a system of equation, I'll have what? I'll show that system of equation doesn't have a unique solution.
Yes.
But here I will have a pair of system of equations. I'll have 2 alpha 2 plus 2 alpha 3 plus alpha 4 equals A. And then I'll have exactly the same thing except that I will change them to betas. So mangyayari ay magkakaroon ng 2 alpha 2 plus 2 alpha 3 plus alpha 4 equals A,
A,
which at the same time would be 2 beta
2
2
beta 1, 2
To
beta
beta 2,
1, 2
to
beta
beta 2,
2, 2 beta 3.
to beta 3. No. 2 beta 2, 2 beta 3 plus 1 beta 4.
right? But this looks exactly the same as the first expression, with just the beta switched to alphas. Right? Okay, perhaps we can do it using the observation. So pag sinolve ko yung equation na yon, magkakaroon lang ako ng mga alphas and betas, but they will just be mirror images of each other. I mean, not really mirror images, but they will be the exact thing na napalitan lang yung Greek letters involved. So, okay, what I'm thinking of here is this way. Let's use the fact that we already know a representation for 1, 1, 1 in terms of the other three vectors, right? So if you have an ABC, you can represent it this way, all right? For any generic vector ABC in R3. Let me just copy the first three expressions here into here, but I will write alpha 4 times our representation earlier for 1, 1, 1. All right. Nasaan yung representation natin kay 1, 1, 1 here? Okay. So what I did is copy the first three terms in the linear combination, the generic linear combination. And then I'm going to replace 1, 1, 1 using the linear combination representation for it using the first three elements. So 1, 1, 1 pa rin itong nasa huling parentheses, right? And the equation is still valid. Okay? And then I'll add things up using associativity and commutativity of vector addition, distributivity of scalar multiplication over vector addition, and then the associative property of scalar multiplication. Eventually, will allow us to write it as what? Alpha 1 plus a quarter of alpha 4, 0, 0, 4, plus alpha 2 plus half of alpha 4 times 2, 2, 0 plus alpha 3, 2, 0, 0 plus 0, 1, 1, 1. Okay, do you agree? Tama ba yung pagkakasimplify ko? It's been a while since I did calculations like this. Tama ba? Hello guys, is that correct? Alpha 2 plus 1 half alpha 4, 2, 2, 0, alpha 3. Alpha 3, ano nangyari kay alpha 3? Plus 0, okay. All right, so I think this is correct, right? So here, what we found is this. As long as alpha 4 is not equal to 0, so if alpha 4 is not equal to 0, then we have found two different representations for the vector ABC. All right, so the vector ABC, we said, okay, suppose it has this representation with alpha 4 not being equal to 0. All right, so that's one representation. The scalars are alpha 1, alpha 2, alpha 3, and alpha 4. But from our previous analysis, we have shown that 1, 1, 1 can be written as a combination of 0, 0, 4, 2, 2, 0, and 2, 0, 0. In fact, this is that precise representation. So by substitution, I just replaced 1, 1, 1 by that linear combination. Okay. And then I played with the different properties of my vector space with respect to vector addition and scalar multiplication and came up with this. So you can think of this guy as our beta 1, this guy as our beta 2, and this one to be our beta 3, and this one to be our beta 4. Now we have found 4 scalars, beta 1, beta 2, beta 3, and beta 4, which generates ABC. And the nice thing about this is that this quadruple of betas is different from the quadruple of alphas. So therefore, we have derived a different representation for ABC. Now in terms of beta 1 until beta 4, which are different from the alpha sub i's before. Okay? Is that clear? Does that make sense?
Yes, sir.
Yes, and actually ito yung parang idea dun sa ginawa nating counter example earlier when we wrote 222 as a different linear in two ways, two linear combinations. So that's the value of starting doing tangible things first. So posibleng try niyo muna sa isang specific example and try to generalize using that particular example. All right? Okay, I hope that's fine. So that's example 8. So makikita nyo later, I hope you guys will remember our solution to example 8 because it will be crucial for our development of basis and linear independence. So you will see that later. But that was our trick. We found out that 1, 1, 1 can be written as a linear combination of the other 3. That means 1, 1, 1 actually is not needed in the representation of the vector ABC in our vector space because you see, this representation puts a 0 coefficient over 1, 1, 1. Ibig sabihin, pag yung isang vector na sulat mo na sa linear combination of the first few vectors, then that vector will not really contribute anything to any linear combination. Kasi the information 1, 1, 1 carries is also carried over by the first 3 vectors already. So with associated scalar factors here. So hindi mo pala siya kailangan para ma-generate yung ABC. Kasi yung information that would have been contributed by 1, 1, 1, which is say alpha 4 in here, can be obtained by using information from the first 3 vectors alone. All right? And that will kick in when we talk about basis for vector spaces. All right? I guess that was a nice discussion. I like it that you are involved in the thinking process. Okay. Now, if that's fine, can we proceed to Theorem 5 now? Let's try Theorem 5. Okay. Yeah, I'm thinking about discussing the proof of Theorem 5 because this will give us a nice review about how to prove statements like this, for instance, right? So statement 1, it is claiming that Lx is a subspace of V. Oh, but by the way, here, I guess I was very careful in writing the proof of Theorem 5 in the sense that I broke it down into 2 cases. Case 1 is if X is the empty set, because L bracket curly L of X behaves differently when we have X to be the empty set and if X is a non-empty set. That's why I needed to divide the proof into 2 parts. So the first part of the proof assumes that X is the empty set. And by the convention we stated before, whenever we write L of empty set, that is just a trivial subspace. And we said it's a trivial subspace, so indeed it is a subspace of V. So statement 1 is already proven. Okay? Now let's try to prove statement 1 for the case that X is non-empty, correct? So let's look back at the statement. So let's now assume that X is non-empty. We want to prove that L of X is a subspace. Remember, we said from now on, we will use Theorem 3, the compact criterion, in order to show that a set is a subspace. All right? And that's what I'm going to do for statement 1, case 2. Okay, I'll go here. So since X is non-empty, again, I want to use theorem 3. So I want to show that the set curly L of X is closed under addition and scalar multiplication, right? So what I'll do is to assume that V and X, actually, this should be, yeah, kindly correct your notes again. This should be L of X. Kasi gusto kong i-prove that curly L of X is a subspace, right? So what I'll do is to take two arbitrary elements of that set, which I claim to be a subspace, all right? So let V and W be elements of L bracket X. Then the fact that it is in curly L of X means that it is a linear combination of some members of X, all right? So that means V and W can be written in the forms you see in equations 36 and 37 for some scalars alpha I, beta I, and some elements of big X. Now, I said that you'll be asked in the homework why V and W can be written this way. Probably I just need to clarify this one. It is clear that it can be written as a linear combination of elements of capital X, right? So clear yun, kasi nasa bracket L of X sila. Pero why specifically can I write them in the forms given in 36 and 37? All right. Ano yung posibleng maging implication on, or what could be the complications of that? Well, for one, I am saying that V and W are generated by exactly the same exabytes, and hence the use of the same notation exabytes, right? Remember that you will be a member of curly L of X if you are a linear combination of some elements of X. It doesn't say how many elements of X, or should we use all elements of capital X. It says it should be a linear combination of some elements of capital X. So sinabi ko, okay, si V, dahil nakay curly L of X siya, dapat masulat ko siya this way, which is fine, right? I will use n elements of capital X, pair them up with scalars alpha 1 until alpha n, and then I'm going to use x1, x2 until xn. I suppose those are the elements of big X that can generate V. Pero look at equation 37. I am claiming that W, another generic vector, can be written as a linear combination of the same X sub i's that I used to generate V, kasi parehas yung notation nila dyan, right? That means I am claiming that V and W can be written as the linear combination of the same elements X sub 1 until X sub n. I'm even claiming that I will use n elements of capital X to generate V and W. But, yeah, but why can I do that? Clear ba yung question? Or do I need to repeat it again? Or dina-digest nyo pa yung question? Nakita nyo ba yung complication, or, I mean, the specificity of 36 and 37? Or probably let me put it this way if it's not that clear yet. Si V, element siya ng curly L of X. That means V is a linear combination of n elements of X. All right, that's clear by definition of Lx, of curly L of X. But if I also have a W in curly L of X, then W is a linear combination of some members of big X. But that some members of big X is not necessarily the same members I used to generate V. So in a more generic terms, W has this representation: beta j, y sub j, j going from 1 to m. I might end up using more elements in generating W than generating V. And the elements I use to generate them might be different from each other. All right? But if you see in my proof in 36 and 37, I said that V and W can be written using the same exabytes and using the same number of such exabytes. So why is that valid? I'm saying it is valid, but why? That's what I want you to explain in the homework. Kasi again, si V masusulat kong ganito. Si W masusulat kong ganito. And that's all the definition of curly L of X require. All right? But yet, I am claiming in 36 and 37 that I can write W using, or V and W using the same X sub 1 until X sub N. Where in fact, the only thing guaranteed by the definition of curly L is that these two representations, which might not be related to each other at all. All right? So you need to justify yung ginawa ko sa 36 and 37. Why was I able to write V and W using the same members of capital X? Okay? Pag-isipan niyo yun. Probably I'll give, I guess there are 2 or 3 of you who already submitted their answers to that question. Probably I'll give you a chance to modify your answers if you'd like. So just send me an email if you want to update your answers to that. Okay. So, but I hope that's clear, right? Okay. Now let's move on with the proof. Suppose we already justified that 36 and 37 are right. Then if I add them, because again, my goal is to show that curly L of X is closed under addition. So I added V and W, and then I also added the 2 sides of the equation, and I got this. And then by closure, alpha I and beta I are also scalars, right? And then using associativity and commutativity will tell us that this is another linear combination of elements of X. Exactly the same elements, x1 until xn, we used to generate V and W, but the scalars now for V plus W would be the sum of the scalars we used for V and W respectively. All right? So that means V plus W is in curly L of X. Okay? Now, same argument goes for closure under scalar multiplication. Okay? Now, titingnan ko si alpha V, right? But I know that V has this representation. So by substitution, I can do that. And then by distributivity of scalar multiplication, I can put this inside the sum, okay? And get this line over here. And then use associativity of scalar multiplication, I can group the scalars here, okay? So what do we have in this last expression? This is in F. The exabytes are in big X. So that means alpha V is also a linear combination of elements of X. So therefore, alpha V is in curly L of X. And then by theorem 3, then we say that curly L of X is a subspace of V. Okay? Is the proof clear? So I hope by now you'll be able to write your own proof using theorem 3. Okay, that's fine. All right. I leave the reading of case 1 to you guys. I'll just focus on case 2 kasi medyo trivial yung case 1. And then also in the interest of time, let's try to see how statement 2 was proven. Every subspace of V containing X also contains L of X. So kung meron tayong set V, tapos kukuha ako ng subspace niya, let's say W is a subspace, and W contains capital X, so andito daw si X sa loob, ibig sabihin si curly L of X dapat daw na kay W din. So si curly L of X ay mukhang ganun yung itsura. But it should also be contained in the subspace V. So essentially what we want to show that, I think I wrote that here. Okay, so here in the proof, I assume that I have a subspace W of V, which contains capital X. And then we want to show that curly L of X also is contained in W. Right? Yan yung inclusion na gusto natin ipakita. And recall that whenever you want to prove inclusion, you want to show that if you start with an element of this guy, that is also an element of W. That's how you prove being a subset, all right? So I want to show that curly L of X is a subset of W, so I will start with an element of curly L of X. And I want to show now that V is an element of curly W. Because if I'll be able to do that, then automatically by definition of subset, curly L of X is a subset of W. All right? So ngayon, ang goal ko na lang, start with the V and show that V also belongs to W. Okay? But how can I show that? Well, try to analyze it with what the information you have. So here, the only assumption we have so far is that V is in curly L of X. So dahil na kay curly L of X siya, linear combination siya ng elements ni capital X. So there will exist elements of capital X and scalars in the field F such that V is this linear combination. Okay? Now, gusto ko mapakita to ay element ni W. Let's see how. Let's look at each of the addends or each of the terms. Well, what can we say about xi? Well, the xi's are element of big X. But big X is a subset of curly W. So, ibig sabihin, itong mga X sub i's ay na kay curly W din. Right? And so, kung na kay curly W siya, by the closure of scalar multiplication on a subspace W, that means this guy is also in W. Agree? Kasi yung mga scalar multiples ng element ng isang subspace ay dapat nasa subspace din. Right? By Theorem 3 or by the definition of being a subspace, closure of the scalar multiplication. Right? And then, what can we say about the summation then? Nagsasum ako or tinitake ko yung sum ng mga elements ni W. So what do I expect out of the sum? Do I expect that the sum will also be in W? And I guess
Yes,
that's true because of closure under vector addition. So that means this is also in W. So I started with an element of curly L of X, and I ended up concluding that that generic element is also in W. So by definition of subsets, then curly L of X is a subset of W. And we're done. Okay? Now let's take a look at the third statement, unless you have questions. Okay. The third statement is about curly L being the intersection of all subspaces of X, all subspaces of V containing X. So we are talking equality here of two sets, L of X being equal to the intersection of all subspaces. And do you remember, guys, how to prove equality of sets? What's the usual way of showing equality of sets?
You show, sir, that each is a subset of each other.
Right. So we show that one is a subset of the other and vice versa. And I hope that's what I did here. Hopefully hindi ako nag-shortcut. Okay. Yeah, I think that's what I did here. So, okay. So I called the intersection of all subspaces of V containing X to be curly U. Okay. So I said here that since L bracket curly L of X is a subspace of V by statement 1. Yeah, I hope you all agree. Ito lang yung pinrove natin sa statement 1. Tapos si X ay contained sa L bracket X. Tama? Kasi lahat ng elements si capital X ay linear combination ng sarili niya times unity. So lahat ng element ni bracket X, ni capital X ay naka curly L of X. Alright? So therefore, si L of X ay isa dun sa mga ini-intersection natin to get curly U. Remember, curly U is the intersection of all subspaces, W. Alright? Pero si L of X ay isa dun sa mga nandito. Isa siyang W. So isa siya dun sa mga ginagamit ko dun sa intersection. And remember that the intersection of sets is a subset of every one of those inside the intersection. Alright? That's how I got this. Yung intersection ay subset ng bawat isang set doon sa loob ng intersection. Right? Or another way of putting it is that A intersection B is a subset of A. Mas malaki yung A kaysa sa A intersection B, right? Same thing goes here. U ay intersection ng lahat. Pero si curly L ay isa dun sa mga nandun sa intersection. So ibig sabihin si curly L dapat mas malaki kay script U, kay curly U. And that's how I got the first. Okay? And then the reverse inclusion directly follows from statement 2, right? So kasi gusto kong ipakita naman si L bracket X is a subset of U. So, bakit siya magpa-follow? So, it says here that bakit siya mag-follow from 2? Because 2 says that curly L of X is a subset of any subspace containing X. All right. Okay. I think that is clear here. Kasi si U, intersection siya ng lahat ng subspaces that contains X. So in short, everything, lahat ng subspaces na ginamit ko dun sa intersection, kino-contain kay X. So dapat yung intersection should also contain X. Right? So the intersection should also contain capital X. But the thing here is that L of X, coming from statement 2, curly L of X is contained in any subspace containing capital X. But curly U contains the set X. Curly U is a subspace, and it contains curly X. So that means curly U will qualify as a W in statement 2. So that's why curly L should also be contained in curly U, thus proving the reverse inclusion. All right? Clear ba yun? Para naguluhan ako doon ng konti. But nakuha niyo ba yung yung idea? Bakit siya clear magpo-follow from statement 2? Hello guys. Or naguluhan din kayo?
Sir, medyo nakakalito lang din. So baka better, baka pwedeng in terms of drawing, kunyari ito yung
sige.
nandito sa loob niyan. So ito.
Okay. Sige, tingnan natin. Reviewin natin yung statement 2. Ano yung sabi ng statement 2? So meron akong vector, malaking vector W, vector V pala. Vector space V. Tapos kukunin ko ay isang subspace W. that contains X. Sabi nung statement 2, yung subspace W that contains X must also contain L bracket X. So nasa loob din ni W yung L bracket X. So parang package deal si X at saka si L of X. So kapag ka nasa loob ng subspace si big X, dapat nasa loob din ni subspace si curly L of X. Okay, that's what theorem statement 2 is saying. All right. Now, that means, tingnan natin bakit magpa-follow sa kanya directly yung second part ng proof ng statement 3. Right? Kasi yun lang yung sinabi ko dito eh. Okay? But why will that be true? Well, we know that si W, si U, ay intersection ng lahat ng subspace that contains X. So, halimbawa, si U ay intersection ng lahat ng W provided that W contains X. So, kung si X ay nasa loob ng bawat isang W, so dapat si X ay nasa loob rin ng U. Do you agree? Clear ba yun? Si X ay nasa loob ng bawat isang W. So, dapat si X ay nasa loob ng intersection ng lahat ng mga W's.
Yes.
Ang intersection ng lahat ng mga W's, tinatawag ko lang siya na U. I think that's clear, right? Bawat isa, laman nila si X. So, yung intersection nila, surely laman din si X.
Okay.
Pero sinabi natin si X at saka si curly L ay package deal according to statement 2. Kapag ka nasa loob ng subspace si X, nasa loob din ng subspace si curly L of X. And alam na natin na si X ay nasa laman ni ay nasa loob ni curly U. So dapat si curly L nasa loob din ni curly U, which proves the reverse inclusion. So therefore, curly L is the intersection of all subspaces that contain capital X. Alright? I hope that's better.
Okay, sir.
Kung di pa rin clear, medyo gawin nyo ngayon drawing, no?
Yeah. Thank you, sir.
Alright. Okay. Then let's try to... Oh, yes, Miss I, you have a question?
Sir, in effect, sir, is curly L of X the smallest subspace of V that contains X?
Exactly. That's what statements 2 and 3 are saying. Right. So siya yung pinakamaliit na subspace ni V na nagko-contain kay capital X. Because it is the intersection of all possible, so it could be it should be the smallest. Oh, by the way, one missing thing in the proof is that sinabi ko ba na si U ay subspace? Pero that is from proposition 4, right? That's why I included proposition 4 as well. Just to guarantee that the intersection of all subspaces is another subspace. And that's the missing piece in order to complete this statement. Though I thought it follows easily from those results, but I could have written them in more details there. But the idea is, I guess you get the idea. I need to say that U is indeed a subspace, being the intersection of subspaces. That's where proposition 4 will kick in. Okay. And then, yeah, the set of the subspace curly L of X is also called the subspace generated or spanned by the set X. So some alternative name for curly L of X. This is the subspace generated or spanned by capital X. Can I get, and I think I have 11, I have some examples here. Example 11. I guess example 11 is detailed enough. Pinakita niya lang kung ano yung, what can generate the vector space F3. Though this is a nice example, this is in F3. So yung 1 and 0s that you see here in the vectors in set X are not the usual 1 and 0 as numbers. 1 is the unity in the field F, 0 is the 0 of the field F, right? But nevertheless, the set capital X can generate the entire vector space F3. And I guess this is familiar because this is an example of an elementary basis for a vector space. If you're thinking about R3, if F is equal to R, then 1 and 0 are the usual number 0 that we know. We know that 1, 0, 0, 0, 1, 0, and 0, 0, 1 spans the entire R3. That's why ito yung dahilan kung bakit kailangan mo lang ng tatlong coordinate axes para ma-generate lahat ng points kay R3. Because R3 is spanned by 1, 0, 0. You can think of it as the x coordinate. 0, 1, 0, you can think of it as the y coordinate. 0, 0, 1, you can think of it as the z coordinate. And any point in the three-dimensional Euclidean space can be written in terms of its x, y, and z coordinates. Hindi mo na kailangan ng ika-apat na dimension because we are sure that that fourth dimension will not add any information about R3 that is not carried by the first three dimensions, x, y, and z. Right? But we are using the term dimension very loosely now, but we will define that later in module, I think in module 3 or 4, 2 or 3. Okay. Okay. Now, on the other hand, I said here that the set big Y cannot span the entire vector space F3 because if your set Y is defined this way, then kapag ka meron kang non-zero third component, elements of Y cannot generate that because the third component of all elements of Y is equal to 0. So if you attach an alpha here, a beta here, and a gamma here, the sum will always have a 0 third component. So it cannot generate 0, 0, 1. Kasi wala kang mahanap na alpha, beta, and gamma such that alpha times the first vector plus beta times the second vector plus gamma times the third vector will have third component equal to 1. Okay? That good? And I guess we discussed affine combinations way back, I think in meeting 2. So I think you guys already started there, and I think we supplied a proof for what? For 12. Okay. And then the exchange property, proposition 6 is but a technical result. It means the exchange property siya kasi if let's see why. Okay, this statement is saying that V cannot be generated by elements of X alone without W, right? Kasi si V ay hindi kayang ma-generate na mga elements ni X lang. That is why V is in the set of all linear combinations coming from the set X union W, but it is not in the set of all linear combinations of elements of X alone. So elements of capital X alone cannot generate V. I need an extra vector W added to elements of X in order to get V. So si V, hindi siya kayang i-generate ni capital X. Pero pag dinagdag ko si W, doon sa pang-generate ko, kaya na nilang ibigay si vector V. And if that is true, then W, on the other hand, can be generated with the set X together with the set containing V. So parang they are returning the favor. Parang exchange gift sa kanila to. So V is not the vector V cannot be generated by set X alone. It needs a W. And a consequence of that, then W must be a linear combination of elements of X and V as well. So kaya parang nagkaroon ng exchange property. So because the V here and the W here sort of changed roles. That's why W turned out to be here and V coming from here. But we need to be generic here because W can be generated or is possibly or can possibly be generated by elements of capital X alone. But nevertheless, you can add an extra V there just to be sure. Right. So since we're a little bit out of time now, I have something for scheduled at 2. So I hope you guys will read the proof of proposition 6. I only included proposition 6 not for the beauty of the proof of it, but I need proposition 6 to prove something in module 2. So you will see later. But yeah, the utility of proposition 6 is for a result in module 2. But it would be nice to read its proof. You might get some idea how to go about a problem in the homework. Then just a bunch of definitions here. We say that the vector space V is finitely generated if it has a finite generating set. So it follows then na kapag ka meron kang finite vector space, then it is finitely generated. Because a vector space can be generated by itself, right? Because V is curly L of V. And if V is finite, then it has a finite generating set. But there are infinite vector spaces that are finitely generated. For instance, R3. R3 is an infinite vector space, right? Because you can define infinitely many triples of real numbers. But R3 is generated by 1, 0, 0, 0, 1, 0, and 0, 0, 1, right? Though R3 is an infinite vector space, it can be generated by 3 elements alone, 1, 0, 0, 0, 1, 0, and 0, 0, 1, right? So that makes R3 a finitely generated vector space. So some infinite vector space are finitely generated, but all finite vector spaces are finitely generated. Now, I think I have an example here of a vector space that is not finitely generated. Yeah, the vector space of all sequences is not finitely generated over a field F. Ano pa example? Can you guys think of another example ng vector space na hindi finitely generated? Actually, I think I gave one. We discussed one earlier. Can you recall what that vector space is? Vector space na hindi infinite na hindi finitely generated.
So iba yung set of all polynomials?
Yeah, that's right. The set of all polynomials is not finitely generated because if you remember, we said that if you will stop at a certain degree, kasi di ba dapat finite yung generating set. So pag meron kang 1, x, x squared, x cubed until x to the n, you will only be generate all polynomials of degree n or less. And you will not be able to generate any higher degree polynomial. So it really requires the use of all monic polynomials, not all monic, but all polynomials of the form x to the n, where n is a natural number or 0. So that's another example of an infinite vector space that is not finitely generated. Okay. And then kindly read the rest of the examples, and then let's talk about homework 2. So yes, Ms. Ao.
Sorry, sir. I was about to ask question from the homework. It's okay, sir.
Yeah.
I will wait.
And that's what we're gonna do today. So hindi ko na binawasan yung items. Each of the problems in homework 2 is worth 5 points. So expect that the solution are not that long as what you encountered in homework 1. So if you're doing something very long, then that means you are doing an overkill for the problem. There might be an easier solution, right? So let's see. I I guess problem 1 is pretty straightforward. Though, do you have problems or difficulties with it? Oh, guys, wag mahiya. Magtanong if you have questions with problem 1. Or is it okay? Is it straightforward? Any problem that you encountered with it? Wala? Okay, so I will expect good answers for problem 1. Let me think a little bit. What could be a possible complication here? Actually, wala naman, no? So, direct application lang, i-check nyo lang yung
So,
6 na
wala
conditions.
po. Straightforward po yan.
Yep. How about problem 2?
So, problem 2, we need to prove both existence and uniqueness, right?
Right. Mhm. So whenever you have a statement that claims that there exists a unique element of your space, or there's a unique there's something unique, right? The first thing you need to do is to prove the existence. Pakita nyo muna na may nag-exist. The clue here is that you will start with V and W. V and W are given. They are given to be elements of the vector space. And then the statement is saying that there should exist a unique Y such that this equation is true. So in order to prove the existence, you should give me an element Y. And since all you got to start with are elements V and W of your vector space, then probably you can solve this equation for Y in terms of V and W and claim that solution Y is in fact an element of V. You should not stop by saying, okay, Y is equal to this. That Y is equal to this guy. You should also convince me that your solution Y also belongs to the vector space V. But I guess that is clear, but I want to see that on paper. Why is your solution Y guaranteed to be in V? And then you'll go on to talk about uniqueness. How do you prove uniqueness? Well, a standard way of proving uniqueness is to assume that there is another such element of the vector space that satisfies V plus Y equals W. Call it Z. So suppose this is some sort of a proof by contradiction. So you suppose there exists a Z in V that has the same property. So that is V plus Z equals W. And then we already know that V plus Y is equal to W, right? So you need to dig in for a contradiction. What will happen if we will accept the fact that there is another distinct element Z different from Y such that V plus Z equals W? You should be able to get a contradiction, right? Something that must not be true regarding V and Z, okay? Or you can phrase it as a direct proof. Assume that there is an element Z such that V plus Z equals W, and show that Y is necessarily equal to Z. Okay? Yun yung pagpo-prove ng uniqueness. Assume mo, okay, kunwari may dalawa na magkaiba. There should be a contradiction somewhere. Okay? Or you assume, okay, kunwari may isa pa, and then you show that that isa pa is equal to the original one that you got before. Okay? Okay, any question about problem 3? This might be a little tricky. Curly C of 0, 1 is the set of all continuous functions whose domain is the open interval 0, 1 and whose codomain is R. The addition is defined in a different way here. The sum of two functions is defined to be getting the maximum component-wise. So ang function value ni X under the sum F plus G ay yung maximum ng F of X and G of X. All right? The question is this a vector space together with that operation?
Sir, if you show that there's not one additive identity, will that suffice?
Yes.
Because if it won't have an additive identity, and remember, the additive identity should work for all functions
For all
f, right?
functions. Okay. Thank you,
Yeah,
sir.
so pag wala kang nakitang ganon, or napakita mo na imposible magkaroon ng ganon, then that means it is not a vector space. And indeed,
Okay,
as a clue, this is not a vector space. So you need to reason out why. And you don't need to include checking the other properties. Kasi kahit ilagay niyo yun, I won't give partial points to it. Hindi ko yan babasahin. Skip ko lang dun sa juicy part wherein you show one property that is not satisfied. So do not, you need not waste your time writing all those properties that were satisfied if you'll be able to find one that is not met. All right? Okay. Problem 4.
Sir, for problem 4, is it okay if you are, sir, for vector space, if you prove that it's not closed under the 2 operation that was given, can you already conclude it's not a vector space?
Yes, because closure is actually the most fundamental property.
Yun nga,
So,
sir. The reason I ask, kasi when I ask you if you're gonna prove a vector space, you said we can skip the part of proving it's closed. But for some problems like this one, we have to start with, that's why I asked, kaya ako tinanong yun before, kasi this one, starting with closure, kung magka-problema ka na, do I still need to look for other properties that it doesn't follow? It won't work?
yeah. No, you don't need to find others because in the definition, hindi naka-number yung closure kasi sinabi na let there be a binary operation, right? Or
Okay,
it's an
sir.
operation from V cross V to V. So implicit yung assumption that they are binary operations or may closure yung set under the operation. But in this case, number 4, we are not sure that it is a vector space. So you need to show, it is sufficient to show that it is not closed, say under vector addition or scalar multiplication.
Okay, sir.
But I'm not
Thank
sure
you.
if close ba siya under scalar multiplication. Mukhang close siya under scalar multiplication.
Sir, hindi.
Ay, hindi ba? Okay, so you can try to show that on paper, all right? But only one reason is sufficient. So if you find one property that is not met, then you're good to go. Another way of doing it is that since this is a subset of the set of all functions, right? It is a subset of the set of all functions, and you have the same operations on it. Alam na natin kung ano yung zero vector sa set of all functions, tama, with the usual operation. So if you'll be able to show that that element or that zero vector is not an element of this set, then you're good. Kasi isa lang yung candidate para maging additive identity. So kung yung additive identity na yon ay wala dun sa set of all functions that are never zero, because we are dealing with the same addition and scalar multiplication with the set of all functions, then that is sufficient. But I guess Ma'am Au's suggestion earlier was better because
Mas
i-atakin
madali
mo na
lang.
yung fundamental property. Mas madali yung?
Sir, mas madali lang yung sa closure kasi.
Okay. Yeah. And actually, that's the first thing that you will check, right? At least intuitively or on your mind. Pag
Okay.
nag-add ba ako ng dalawang functions that are never zero, will I get a function that is also never zero?
Sir, in the future, when you ask us to prove vector space, do we start with closure? Kasi yung instruction nyo last time, normally you would give ganito. So we need not check being non-empty and not closed.
Yeah.
So is it better, sir, if we check for closure also?
Or you can just put a sentence saying that it is a binary operation. I don't
Okay, sir.
need to see the proof. So, okay, better yet, in succeeding homeworks, I will say that let consider the following binary operations para hindi nyo na siya kailangang i-prove given as a question na binary operation siya. Pero pag hindi ko sinabi na binary operation siya,
okay, sir. Sige po.
pag hindi ko sinabi na binary operation siya, kailangan nyo siyang i-check or at least put a statement kung talagang close siya. So, but for proving it is not a vector space, probably it's a good thing to check for closure first.
Okay. Thank you, sir.
All right. And then problem 5, I hope clear na ito. I hope clear na yung question about why are the representations in 36 and 37 valid. So, and then again, I already received answers to problem 5. So if you guys want to amend your solutions there, just send me an email. Hopefully hindi ko sinulat yung sagot dun sa submission nyo. But yeah, if you want to redo your submission to problem 5, because it might not be clear the way it was stated. So yeah, you can do that until the deadline.
So, sir, dito sa 5, that VW are now element of the curly LX, right, sir? Kasi nahirapan din
yeah.
ako, iniisip ko na nasa X. Hindi ko ma-imagine. So, it's the curly LX. Okay.
Right. So it should be in curly X. I guess there's also a typo above. So yeah. So curly L of X. So si V and W ay linear combinations ng elements ni X. But the way I wrote them in 36 and 37, sinulat ko sila na linear combinations ng parehong elements, pero magkakaiba lang yung scalars. Pero sa definition ng pagiging linear combination, hindi required na gamitin lahat ng elements. Hindi required na pare-parehas yung elements. But why was I able to write V and W as a linear combination of the same elements, of the same number of elements of X? Ano yung trick? On how, what is the trick that allowed me to write that representation? Because that representation is crucial in the next portion of the proof, and I added V and W, right? So, yeah. And then gagamitin ko na naman yata ito sa isang proof sa module 3. So, kaya gusto kong tingnan kung kaya nyong i-reason out why that representations are valid. And then problem 6, I think this is also straightforward. You want to show that this is a proper subspace. So that means you use Theorem 3, closure under addition and scalar multiplication. But you need to mention that this is not trivial and it is not the entire R3. Okay?
Okay, sir.
Problem 7, ito yung pinaka-theoretical problem here. Any questions about it?
Sir, mahirap isipin.
Mahirap isipin. Let me see. Okay. So, meron kang vector space. Ito yung set mo. Ito yung, don't forget this property.
Ayun nga po eh. So, pag yan, sir, I was trying to put it in a set, tapos ini-imagine, ayan. Sir, medyo mahirap lang isipin agad.
Maybe you can start by doing it mechanically. Kasi gusto mong i-prove yung equality, diba? So if you want to prove equality, so you prove the double inclusion. Yes, sir, really? Question?
Sir, yung when nga po, sir, yung when proving equality, so we can use the show that curly L of x1 is subset of curly L of x2, and the curly L of x2 is a subset of curly L of x1.
Yes.
Yung dun sa last part, sir.
Itong
in particular.
Yung sa in particular, kailangan nyo lang piliin ano si x1 at si x2. Let me address the first question first before going to the particular case, right? So siguro for those who haven't started yet, you can start your solution this way. So you want to show the dual dual inclusion, right? So you start with, say, you take an element V that is in curly L of x1, and your goal is to show that V is in curly L of x2. All right? So ngayon isulat mo si V kasi ito yung assumption mo ngayon. Isa lang yung pwede mong gawin. Isulat si V as a linear combination of elements of x1. And you want to show that V is also a linear combination of elements of x2, right? That's the end goal. Show that V is a linear combination of elements of x2. Now, your assumption, L is in Lx1, so it is a linear combination of elements of x1. But look at what is assumed in the problem. The premise is that x1 is contained in x2. So lahat ng elements ni x1 ay element din ni x2. So it is quite obvious why V must be a linear combination of elements of x2. Because elements of x1 are also elements of x2. And you just need to put that on paper, right? Parang sinolve ko na rin siya, no?
Salamat, sir.
Kaya medyo binilisan ko yung pagsasalita so that para hindi nyo makatch. Pero yun na yung actually yung proof, right?
Yeah.
So, but I hope you see the process. So, pwedeng mechanical yung pag-analyze. So, try what you want to do. write what you want to do, and then...
Sir, yung reverse would be you get naman an element in L of x2 and then show it's in L of x1.
Right. So show that this is in L of x1. And I guess this is a little bit trickier.
Oh, mas
Right.
mahirap lang, sir, kasi pabaliktad.
Aha, right. So kung
And then-
naka L of x2 siya, I think gagamitin mo dito yung ilan dun sa mga theorem from above. So V is in Lx2, right? So, but Lx2 is, what can we say about it?
Sir, applicable po ya dyan ba yan kay Ginina, yung curly U, L subset of L of
Mhm.
X, and L of X
Yes.
subset of curly U?
Yes, yun yung gagamitin
And
nyo
ano,
dito.
parang,
Kasi ano ba masabi natin? Si Lx2, okay, actually ito na. Okay, natitempa kong sabihin, pero ito na yung proof eh. One-liner din yung proof eh.
Sige na, sir.
Pero you will write it on paper naman, no? So, okay. I want to see how you write. Okay. Lx1. Saka medyo marami pala to, 8. I was thinking 6 lang to, kaya ayokong
Sir,
bawasan. Ano
madami.
pala siya?
8 po siya.
Okay. Now, what can we say about Lx2 again? Lx2, what do we know about Lx2? Actually, hindi ko na pala kailangan to eh. Parang one-liner lang yung proof. So what can I say about Lx2, curly L of x2? It is a subspace of the vector space, right?
Oh.
So ito ay a subspace, and it is a subspace. Di pala baliktad. Makukuha ko pa rin yung pakabila.
Kabila po.
Right. Ito na lang. Okay. L of x1 is a subspace. And then we said that any, remember, eto na, sabihin ko na rin yung sagot eh. Sana tama. Double check nyo na lang. Okay, so let's focus on this statement. Every subspace of V that contains X also contains curly L of X. So parang in drawing, vector space V, ito yung package deal natin, di ba? Meron kang W, laman ni W si X, dapat laman din ni W yung L bracket X. Alright? Okay. I'm thinking that can be applied to problem 7 because here, anong alam natin? Si Lx1 ay subspace, agree? Set of all linear combinations ng kahit anong subset ay subspace. Theorem, first statement of that theorem. Theorem 5.1 nga ba yun? Right? So this is a subspace. So since this is a subspace, by assumption it contains X2. So yung package deal, statement 2 will hold. So that means Lx1 must also contain Lx2. Agree? Or malabo? Come on, guys.
medyo okay lang, sir.
So ulit, ano yung theorem 2? Kapag ka meron kang V, statement 2, anong theorem yan? Theorem 5 nga ba yan? Meron kang V, vector space. Meron kang subspace, W. Pag laman ni W si X, dapat laman niya na rin yung curly LX. That's the package deal between X and curly LX. Pag laman mo si X, laman din dapat ng subspace yung curly LX. Alright. Now, we know that I have the vector space V. Lx1 is a subspace by theorem 5.1. Alright? But by assumption, Lx1 contains X2. Right? Ito yung assumption na dun sa problem. X1 subset of X2 subset of Lx1. So ibig sabihin si X2 nasa loob ng subspace Lx1. Package deal. Dapat daw yung Lx2 nasa loob din ni LX1. So therefore, LX2 is a subset of LX1, which proves the reverse inclusion. Clear? Hindi pa rin?
Okay na, sir.
Okay, good. How about the others? Medyo tahimik yung iba. Feeling ko 3 or 4 lang tayo nagdi-discuss eh. How about the others? I hope it's fine.
Okay naman po, sir.
Right, huwag kayo mahiya magtanong ah. Kasi pagka hindi kayo nagtatanong, I will assume that you know everything. Kasi, yeah, dalawa yung assumption ko whenever nobody is asking questions, right? No question type 1, everything is clear, you don't have any questions at all. Type 2, you don't understand anything to that point that you cannot formulate a sensible question. So usually sa face-to-face classes, makikita mo sino yung no question type 1 and no question type 2. But in an online environment, parang mahirap i-gauge yung wala kang facial expression na makikita, yung demeanor, hindi mo makikita yung blank stares nila. So I don't have any way to gauge if you have a type 1 or type 2 situation there. But I hope you guys have a type 1 situation. Okay. So
Sir,
kaya, yes.
Sir, pwede pong gamitin yung Venn diagram, tapos may konting explanation pagka magpo-prove na.
Yeah, pwede. Sure, if that is more comfortable for you, pwede. But try to write it also in a narrative form because we're trying to write proofs here. So parang essay yung gusto ko makita. So if you can picture it properly, then I hope you can also write it into a narrative or into an essay, right? Though you can start with pictures first, usually. Ganun din ang ginagawa ko kahit sa real analysis pag nagpo-prove, laging drawing muna. Kasi hindi ko maintindihan yung mga concepts hanggang ngayon. So kahit nga sa unit circle pagka tinanong ako what is cosine pi over 3, hindi ko kayo masasagot kagad. Kailangan ko mag-draw ng unit circle, tas isulat silang lahat. Kasi sometimes you work visually. So it's fine if you do things visual first and then try to write it formally later. Okay, problem 8.
Sir, can I go back to problem 7?
Yung in particular ba yan?
In particular, sir.
Right.
Do we get an element of...
Well, for the in particular part, so pag may mga statements that says in particular, following a certain statement, that is usually just a special case of, that will just be a special case of the theorem before. So if we are saying here that, okay, Lx1 is equal to Lx2, provided that this inclusion is true, then kung meron kang in particular statement, katulad nito, kailangan mo lang hanapin what is x1, what is x2, or what can I take to be x1, what can I take as x2 in order for this premise to apply, right? And then so I can make the proper substitution with that x1 and x2, and I'll use this theorem, the theorem that we have just proven.
Okay, sir.
So ano yung piliin kong x1, ano yung piliin kong x2, such that totoo itong inclusion na to, and so magfa-follow itong statement na to. Though the clue is, by just looking at the form of it, mukhang, hindi pala siya masyadong clear, but I want you to play with it. Question lang is, what should I take to be x1 and what should I take to be x2 so that this statement remains true and that I can conclude that Lx1, which is this guy, will be equal to Lx2 or that guy, or the other way around. Okay? So wala kayong ipoprove dun sa in particular. Bigay nyo lang ano si x1, ano si x2, na pag in-apply ko yung theorem, ito yung makukuha kong statement. Okay? And then last question, any problems with 8?
Sir, yan po. Is it, ang tanong ko, subset of V containing only E o containing E? Kasi sir, when I try to check for closure, kapag maraming element pa yung X aside from E, parang hindi ko na masatisfy yung pagiging affine. But your question is show that it's a subspace.
Yeah, for sure. Kapag ka si si X ay kahit anong subset na nagko-contain kay E. So it can contain more than one element, but necessarily the zero vector should also be in the set X. Okay, so let's try that. Nakikita ko yung problem kasi sa pagiging affine, dapat yung sum ng mga scalars ay equal to 1, right?
Oo nga po eh.
So you need to be a little cunning here. I don't know if that's the right term. Paano mo ipapasok si E? Okay, now you need to prove that this is a subspace. So let's try to use Theorem 3, the compact criterion. So you let X and Y be an element of a capital X, right?
Mhm.
Tapos gusto ko ipakita na si X plus Y ay nakay-affine din. Okay? Right. So si X, dahil nasa affine siya, pwede siyang masulat na ganito. Si Y, nasa affine siya, pwede ko siyang masulat na ganito.
But the Li's and the FBI's are equal to 1.
Right. The sum of alpha I, sum of beta I must be equal to the unity. Right? Yan yung condition. So when you add them, kakaroon ka ng X plus Y equals alpha I, Xi plus beta I, Yi. Okay?
Mhm.
Na obviously linear combination pa rin siya, tama ba?
Apa.
Pero pag sinama mo na yung scalars, ano na yung scalars natin dito? Yung sa linear combination ng X plus Y. Parehas na, yung mga alpha at mga beta at the same time. Right? Tama? So this is a linear combination. You can think of it as a linear combination. Gamma I is Zi, right? Where yung lambda, where yung mga lambda at mga beta, sila rin yung mga gamma, right? So you can think of gamma 1, the first half of the gammas are the alphas, and the second half of the betas are the gammas are the betas, right? And then the first half of the Zi's are the Xi's. The second half of the Zi's are the Yi's, right? Pero pag kinuha mo na yung sum ng mga ginamit mong pang linear combination, ano na yung sum ng mga gamma I?
So hindi ba more than 1?
Yes. Kasi sila lang yung sum ng mga alpha at saka mga beta, right?
Opo.
So ito ay maging 1 plus 1 equals 2.
2.
Actually, tama bang isulat ko siya na 2? Hindi ko pala siya dapat isulat na 2. Dapat 2 times unity. Kasi hindi siya necessarily numbers. So,
Apa.
pero yung 1, placeholder natin for unity. But it would be 2 times 1, which is not necessarily equal to the unity. Alright?
Apa.
Pero we are missing one thing. This is the reason why the affine combination, or the affine hull itself, is not a vector, it's not a subspace, because closure is easily violated. But what is the added condition here? We're not just talking the affine combination or the affine hull of any set, but a set containing the zero element. Right?
So sir, if you force mo yung isa to be the 0?
Yes. Alin ang ifo-force?
Like one of the beta
Sana-
I's?
Or can we just assume, sir, that the vector space is 0 or something like that?
Hindi eh.
Hindi siya magzi-zero.
Hindi siya magzi-zero eh.
Yeah. Okay, let's go back here. So, meron kang meron kang X plus Y, magiging sum siya ng alpha I, Xi, plus, kailangan ko palang baguhin to, gawin kong beta J, Yj. Para lang masabi na mas general to, hindi magkaparehas yung number ng Xi at Yi's. But you see the point, right? And then, this is a linear combination, but the problem is that the sum of the scalars, which turns out to be sum of alpha I, and the sum of the beta J's, is not equal to the unity. And making it not an affine combination at its face. But the added feature here, ganito nyo basahin yung theorem or yung problem.
Bakit kailangang isingit
sir,
yung zero vector?
So, isang vector, sir, pipilitin mo maging E. Like yung YJ.
Right.
Ganun ba?
Or magdagdag ka
Para
dito ng
zero-
vector E,
Oh.
which doesn't affect the sum, right? Tama? Pag nag-add ako ng zero vector, hindi pa rin siya mag-add up, right?
Oo nga,
Pero
sir.
ano yung coefficient dito? 1 yung nilagay kong coefficient.
Oo.
It won't change, right? But any scalar, let's call it delta. What is delta times E, where delta is a scalar?
E.
E pa
Sorry.
rin.
E pa rin.
Right? So I can put any scalar I want in front of the zero vector because I will end up with a zero vector again. But the zero vector doesn't alter the sum.
Okay.
So ngayon, ano na yung sum ng scalars ko? If I write it this way. But I hope you still agree that x plus y is still equal to the sum of the alpha I xi plus the sum of the beta j yj plus delta e. Clear?
Okay, sir. Yes, sir. Yes, sir. It's clear.
Agree kayo doon, di ba? Right. So
Oh.
ano na ngayon yung sum ng scalars? Sum ng alpha I, sum ng beta j, plus delta, right? That's the sum of the scalars. And I want this to be equal to the unity. Right?
Oh.
Pero ang sabi natin, I have a free hand in putting that delta because any delta I choose will give me back the zero vector as the last term in the expansion for x plus y.
Okay,
Kasi
sir.
wala siyang epekto, di ba?
Ganun
So,
ba yun,
what should
sir?
be
So,
my
ifo-force mo. Sir, ang question ko, so when you express your x and your y, necessarily you have to use up all the vectors in your x?
Hindi.
Or do I really have to include e? Parang kasi if I don't include e, hindi ko makita yung closure. But if I add now the way you do it, then I can express delta into a scalar that will make their sum 1, right, sir?
Yes, that's the idea. Well, yeah, yun yung thing. Kasi pag in-expand mo si x as the sum of alpha times xi, unang-una, hindi mo kailangan gamitin lahat ng elements ni big X. So
Okay.
maybe you can just use n of them. And the definition of being an affine in the affine combination doesn't require any element of x, of capital X, to be used. So posible talaga na ilang vectors lang yung gamitin mo
Okay.
para sa expansion. And it is not necessary that you use the zero
The
vector.
zero vector.
So kunwari siya lang yun. We don't know if the zero vector is one of the xi's. All right? But it's an affine combination anyway. And that's why I also insisted on writing it this way, yj, j from 1 to say m, because the expansion for y might require a different number of elements than the number of elements I needed to generate x, and they might not use the same elements at all. So I might use n elements of x for the xi's, and m different elements for yj, all right? And none of them might necessarily give me the zero vector, all right? So posibleng ganun. But if you take the sum, ito yung isang expression para sa sum nila, right? By just adding the two sides of the equation that we have before, right?
Okay po.
Pero at its form, you're right, it might not be an affine combination kasi yung sum ng alpha at sum ng beta ay
Not
equal
one.
ay hindi 1, right? Or hindi unity. Pero pwede nating i-take advantage na sure tayo na si zero vector ay naki-capital X. So pwede ako magkaroon ng ibang representation for xy that involves the zero vector.
Oh.
At yun yung dahilan kung bakit magiging vector space na siya.
Okay,
Kasi
got it.
pwede kong dayain yung expansion at lagyan
Yeah.
siya ng delta E. Parang cheating, no?
Oh,
Parang tinailer fit ko yung pagkakasulat ng x plus y para magawa siyang isang affine combination. If you go back to the definition of an affine combination, it says that
if you can write X, elements of the affine combination can be written as a linear combination where the scalars sum up to the unity. So pwede mo siyang isulat. It doesn't say how many ways you can write it in that way or what's the specific form. As long as it's a linear combination where the scalars sum up to the unity, then you're good. And
Okay,
here
sir.
we're not violating anything, right?
Oo nga po. Got it.
Xi. Pero medyo madaya lang yung dating.
Yun
Kasi
nga,
yung,
sir. No, kasi sir, the difficulty was, even if it
Aha.
contains E, sabi ko, kasi nga, you had a comment in the module na not all affine are subspaces. So,
Aha.
which is, yun nga, madaling isipin na when you add, hindi yan 1, is scalar and times that, hindi na mag-1.
Aha.
But I didn't realize na adding E to the
set
X,
X.
to the
Aha.
set X, will parang, o nga naman, you can manipulate the linear combination and include that element para maging affine siya.
Right.
Kumbaga, inisip ko lang kasi nung una, sir, paano kukuha lang ko niyan? Hindi ko kukunin yung E. But, yun nga, you can exhaust pala the structure of paano mo siya pwedeng gawing affine.
Right.
Unlike kung
Okay.
walang E, it will never be affine at all. Yung
Yes.
space. Okay, sir. Got it.
Mhm.
Thank
Yep.
you.
That's why in some applications, talking about affine combinations, nire-restrict na hindi kasama yung zero vector dun sa ipang affine combination kasi madaya siya. Parang nawawala yung structure na gusto mong ma-attain with the affine combination.
Okay, sir. Thank you. Actually, we were wondering, but there's something with that E that matters to make it a subspace. Okay.
Right. Siya yung
Okay.
pandaya kasi wala siyang effect yung pag-add ng multiples niya.
Oo nga
Yes,
po.
Miss I. Yep.
Hi, sir. Sir, in terms of representing Y, would it be wrong to use X sub i's also
Well,
to represent a linear combination?
Well, it's fine, but that is you can do that because of question number 5.
Kasi sir, pag ginamit yun, ma-i-isolate
Parang-
mo agad yung
Yeah.
alpha.
Cluttered
yung
kasi kapag ano.
cluttered kasi
Oo.
pag marami ng ganun. Pag pareho kasi siyang X sub I, then you can like factor it, parang distributive property. So, alpha I plus beta I, mas madaling makita.
Yep.
Summation.
Yeah. You can do that. Pero ayoko kasing ibigay yung false impression na na lahat ng elements ay kaya mong isulat using the same elements x sub 1 until x sub n.
Oh, yun
But
din.
I hope you saw the point na okay, y1, y2 and so on. Pero ang idea kasi ay pwede kong gamitin yung mga xi's.
Yung iba zero, sir, di ba? Maybe
Yeah.
isa tayo na. Parang
Yun yung yeah. Natigilan ako doon. So you know why. But yeah. But exactly. Yeah. Question number 5. Kaya gusto kong sagutin niyo yung question number 5 before going to question 8 so that it's clear on your minds na kahit isulat ko siya isulat ko yung x and y as sum of alpha xi and sum of beta xi respectively, right? Posible pa rin yun without creating the false impression that it is always that case. Nagagawa ko lang siya because of number 5, the reason for which yung nadula si Miss I na sabihin kayo niya. All right. Okay, any other questions? None? Okay, so if that's the case, then I hope you'll enjoy solving the rest of the homework. The deadline is when? Tomorrow? Near midnight, so yeah. And then hopefully you will start with module 2 ren after you do that. I think the deadline for for homework 3 was moved to Monday, July 12th. Monday ba July 12th? Or when was that?
Monday po.
Yeah, Monday, July
So, sir,
12th.
yung next session po ba natin, Friday or Saturday?
Is it okay if we do it on a Saturday again? Kasi meron akong research meetings Friday morning and Friday afternoon. So medyo hectic yung Fridays ko. Yeah, so let's do it Saturday. Hopefully we can finish module 2 in a day so that we can also talk about the homework. If not, we can also meet again on Monday So Saturday and then Monday para lang
move
sa
the deadlines. Sure, move niyo yung deadline ulit to Wednesday.
Let's see. Let's see. Depending on your feedback on Saturday. All right.
Okay po, sige po.
Okay. So,
So
okay.
will module 2 be all proving again?
Let me see. Module 2. I guess sort of. Homework
Kasi
3.
sir, I think that's where, well, I think yun po yung difficulty. Well, for me, sir, difficult din for me to do all the proving kasi it consumes, kasi you need to think about it di ba sir?
Yeah,
so
yeah.
parang, dahil hindi siya mechanical, so nag-iisip ka parate, tas bago mo masimulan, and then sabi nyo nga, babalikan mo, and then, because of that reason, ako personally, I cannot move on to the next module until I think about what's happening. Parang ganun.
Parang in one
Sabagay-
sitting, sir.
So
Yeah,
parang
mahirap
iwan
kasi
si
na may
Tina ko
iniisip
po,
ka pa,
nag-imagine kami parang.
Yeah. I guess, yeah, siguro nga ganun. Ganun din siguro ng undergrad. Parang hindi mo matanggap na hindi mo masolve yung isang bagay before moving on to the next one. Pero maybe, yeah, this
Kasi
past
sir,
few years.
Kasi nga sir, I think the fear is if we can't even construct in our mind how to go about it. Parang takot-takot to open another module. Baka mag-pile up lang yung hindi ko alam lalo. So, parang katulad na sinabi nyo na ito gagamitin natin in proving something in module 2 or 3. So, kung yun pa lang hindi ko na naintindihan, then when you try to use it, parang dadami lang lalo yung
Okay, I see.
yung i-imagine ko. Kaya sir, I hope you understand. Kaya hindi rin, ako for me sir, personally, it's not easy for me to just stop and hanggang di ko tapos yan. Then try reading muna the module. Baka matulungan ka. Parang sabi ko, oh no, parang.
Yeah. I totally understand. And every one of us has different learning styles or learning styles. Yung iba ayaw talagang umalis hanggang di nila na fully grasp yung
Sir,
topic.
it's been a while since we've done really proving.
Yeah, I see.
Siguro kung sanay, especially most of us are really teachers in the elementary or high school. So we've done very computational math. So pag we're trying to generalize everything, so it takes a while. Siguro lang sir, in my case, kaya dahil nag-undergrad ako, hindi edu. So kaya medyo nare-recall ko, but still I'm still also struggling imagining things, parang ini-imagine ko tsaka ko pa lang siya.
Yeah, I also understand that. Kaya medyo nagulat din ako when I was given the course description for this course. Because I know that this is a PhD education major in math program. When they gave the course description to me, which I am bound, at least the university rules, at least 80% of it should be covered. Parang na-overwhelm ako kasi I know some of your teachers might not have an undergrad major in math. And some of you might have, but hindi nyo to ginagamit or hindi kayo nagpo-prove kasi when you do teaching, especially high school or elementary, you don't do proving anymore. So kaya medyo kinabahan na ako doon. That's why when I designed the outline, I said, okay, maybe I'll do it for 1 or 2 units, and then I'll move on to a computational part, which would be on unit 4 or unit 3 or 4. So yeah, gusto ko lang masatisfy yung requirement ng university, which is the course description. That's why perhaps in the next revision of the PhD program, maybe we can propose it. Kasi I think last time we proposed a course. Nakita na nga yung problema na yan. That's why we proposed, personally, I was part of the team who wrote a new course entitled Proving and Advanced Problem Solving in Math, which I hope would be a prerequisite to Math 211 or Math 10.1 in the future. Kasi para ma-refresh kayo sa methods of proof. And it would be difficult to study methods of proof at this point, when you are expected to write full proofs right away. So yeah, yun yung magiging concern. But I'll try, what I'll do is until module 3, I guess, medyo merong mga theoretical stuff, but at least I'll try to make at least 50% of the homework more computational in nature. That's what I did in homework 4. But let me see homework 3. Homework 3, mag-check lang ng linear dependence for part 1. I guess that's fine. Problem 2 is linear independence again, but this is your field of rational numbers. So just bear in mind for problem 2, rational numbers lang yung pwedeng scalars. And then let me see. There's a theoretical part which will require you to check if it's still linearly independent or dependent if the field is Z5. So the addition and multiplication are to be done modulo 5. So half-half into computational and not. Problem 3 is proving. Perhaps choose 5 out of 6 naman to. So if you're not comfortable, you can skip number 3 for now. Problem number 4, you see matrices here. You just need to show it is a basis. We'll talk about that later. Number 5 as well. Number 6. So I guess kahit medyo mukhang theoretical yung homework 4, I guess the only proving part is problem 3. And then the rest could be treated as computational in nature. Let's talk more about it after we went through the module on Saturday. And then maybe I can throw in some hints for this homework. All right. Okay. Any other questions? So yeah, let's do the meeting on Saturday again. Probably same time, 11:30 until whatever. Hanggang kailan nyo gusto. So okay. Any other questions? And then let's talk about the deadline then. Kung kailangan nating i-move from 12 to probably 13 or 14. It's fine with me kung mag-move ng deadline, but you need to tell me, okay? You need to ask me to move the deadline, because otherwise I'll just assume that everything is going fine. So don't hesitate to tell me if you're having troubles, if you're having difficulties, and I'll try my best to help you or to accommodate your requests. All right?
Yes, sir.
Okay.
Thank you po.
All right, so I think that's it for now. So enjoy the rest of the day. Enjoy solving the rest of homework 2, and then let's see each other again on Saturday. Bye, guys.
Bye, sir. Thank you.
Bye, sir. Thank you.
Thank you po.
Thank you, sir.
All right.